This is the third mini lecture for section 3.1 of the textbook. The next numeration system we're going to discuss is the Babylonian system. So this is probably the oldest of the systems we're going to talk about. No one is certain exactly when it developed, but it was, maybe started sometime around 3000 BC, something like that. It's a very old system. And unlike the previous two systems, which were based on powers of 10, the Babylonian system is what we call a sexagesimal system. The word sexagesimal means that it's based on powers of 60. So instead of being based on 10s, it was based on 60s, which might seem kind of strange, but there were probably some good reasons for that. Among other things, 60 is divisible by 1, 2, 3, 4, 5, and 6. As well as 10 and other convenient numbers. So the fraction system that the Babylonians used is very convenient because of all those divisors. And they used this system quite a bit when they would conduct commerce. Another difference between this system and the last two is that it is actually a positional or place value system. Unlike the Egyptian and the Roman system, the Babylonian system makes use of place value, just like our system. So in some ways it's very similar to ours, but in others it's very different because it's based on 60s. And of course it uses different symbols. So the numbers 1 through 59 are written using the symbols. There's this symbol for 1, a little wedge shape. And this symbol is kind of a boomerang or crescent shape that represented 10 for them. And then you would combine them to represent other numbers, just like you did with Roman or Egyptian. So for example, if I wanted to represent, let's say, 43, I need 4 10s and 3 1s. Okay, similarly for all the other numbers, all the way up to 59. So up to 59, it works just like the Egyptian system, except instead of using staffs and yokes, you're using wedges and crescents, but exact same system. Okay, now beyond that point, each successive place is worth a successive power of 60. Okay, just like in our system where you have a ones place and then tens, and then 10 times 10 is 100, 10 times 10 times 10 is 1,000, and so on. In the Babylonian system, you had a ones place, a 60s place, 60 times 60 is 3,600, 60 times 60 times 60 is 216,000, and so on. So for example, let's take this string of symbols where I'll have 3 of these little wedges, and then let's say 2 crescents and 6 wedges. Okay, so what does that represent? What number is that in modern notation? Well, the first thing I need to do is identify what is in what place. And typically I would start in the ones place. And here's the pattern to look for. Within each place value, you're going to have a pattern of crescents to the left and wedges to the right, like this 43. The crescents and the wedges. So what I'm looking for here is that kind of pattern. And when I see, at the right, I'm going to expect to see the wedges, and then I'm going to expect some crescents. And then when it turns back to wedges right here, that's where the new place begins. So this right here, this set of symbols, that's in the ones place. And then these 3 guys are in the 60s place. So in the ones place, I have 26. That's 26 ones. In the 60s place, I have 3. That represents 3, but it's in the 60s place now. So it's really 3 times 60. So this would be 180 plus 26 is 206. So this represents 206. Okay, it's the same number. They're different numerals. Remember, the word number refers to the thing itself, how many. There's many different numerals for the same number. Okay, this is a numeral, the Babylonian numeral, for what we usually write as 206. And it uses 60s. So don't try to read this as 326 or something like that. That's what it might be if this were based on tens, but it's not. This is probably the most challenging of the systems, so we'll work a number of examples. First, let's try to write the following Babylonian numeral in modern notation. So let me make up another example. We'll say 2 crescents and a wedge, and 1 crescent and 3 wedges. Try to write that in modern notation. So we're going to convert that to our system. Okay, let me rewrite it down here. And again, I start by trying to identify the ones place. I've got wedges, a crescent, and then it changes again. So this is the ones place. And then I've got wedges, crescents. That's the 60s place. In the ones place, I have 13. In the 60s place, that's two tens and a 1, so that's 21. It means it's really 21 times 60. Let me squeeze that in. So this represents 21 times 60 plus 13. Which comes out to 1,273. Now let's try going the other direction. 8,025 in Babylonian notation. So to do this, let's remember what the places are worth. Okay, remember we had a ones place, 60s place, 3,600, and so on. Okay, typically you're going to start with the largest place that will go into your number. Okay, let me copy these down. Okay, we have the ones place, 60s, 3,600s, that's 60 squared, 216,000, and so on. It just keeps going higher and higher. Okay, but the largest power of 60 that goes into this number is 3,600. So first step, I want to know how many 3,600s do I need? And I'm going to use long division to tell me that. 3,600 goes in 8,025 2 times. 7,200, subtract, and we get 825 left over. So this tells me I need 2 times 60 squared. You have two 3,600s. And then I have 825 still to make up. So now I want to see how many 60s do I need. Divide 60 into 825. So it seems to go in there 13 times, and I have 45 left over. So this tells me that I need 13 60s, and then the 45 that's left over. So now I need 2 of these, 13 of these, 45 of these. So we need 2 wedges, a crescent and 3 wedges, four crescents, and 5 wedges. Okay, and that's how we represent 8,025. Okay, so yeah, these problems are a little more challenging, I think, going back and forth with Babylonian. So we'll probably talk about it quite a bit when we discuss the homework, but make sure to attempt them on your own. Now, let's talk about one thing that sometimes comes up with these numerals. Think about this number 3,602. Well, this number requires 160 squared plus 0 60s plus 2. So we have a 1, a 0, and a 2 basically that we want to use to represent this. So we have the 1, 3,600. Then we don't have any 60s, so I'm just going to leave a space. And then we've got the 2 1s. Okay, but obviously there's a little bit of a problem with something like that because it could be easily misread as 3. You know, if you didn't put enough of a space, you know, got copied down, or maybe someone was a little bit sloppy writing, or you just aren't sure how far the space has to be, you could misread that as 3. And that could lead to a lot of errors, obviously. So to make sure that that didn't happen, that the places didn't run together, the Babylonians introduced a placeholder symbol. So to represent 3,602, they'd have the 160 squared, and then they had this little symbol, which means no 60s, and then the 2 1s. Okay, so this symbol is a placeholder. It just says, skip this. There's nothing there. There are no 60s. And it prevented, you know, this guy from running together with these guys. So basically, it's playing the same role that 0 plays in our system. However, the Babylonians apparently did not have the concept of 0 as a number. They didn't think of it as a number in the way that we do.